Graph Theory, Fleury's algorithm, and page 9. So we know how to decide if we have an Euler path or Euler circuit, but is there a way to find one without using trial and error? So we have this algorithm that says if a graph has no odd vertices, start at any vertex. If the graph has two odd vertices, start at either one. The second part is number the edges as you trace through the graph, making sure you don't travel any edge twice. I hope I demonstrated that before. 3. At any vertex where you have a choice of edges, choose the one that isn't a bridge for the part of the graph that has not yet been numbered. So for example 9, just like I did with example 8, I made a decision to go ahead and find the degree of every vertex of the example. So I will pause and do that. Okay, so with example 9a, we notice that we have exactly two odd vertices. Therefore, I know I do not have an Euler circuit. So that means that I at least have an Euler path. So I could either try to start at vertex F or vertex B. I am going to make a decision to start at vertex F. Okay, so I've actually found this path before, so I will not, show the same mistakes that I did before. But I'm going to go ahead and go straight to C, and then to B, and then from B to E, from E to F, from F to A, from A to E, and then from E to D, and from D to B. And as you see, I have used every single one of these edges, and I ended up at B, and that was an odd vertex as well. So let me go ahead and write my path. Okay, on B, it looks like we're going to have an Euler circuit. So if I can figure out the Euler circuit, that means I will also have some sort of Euler path as well. So I'm going to go ahead and start at B. So I decided to go from B to G, G to C, C to F, F back to B, and then perhaps from here you could see that this particular circuit is fairly easy to find. Okay, so let me go ahead and write down that circuit. So again, remember, if it has an Euler circuit, it is also an Euler path. So I'll put same for the Euler path. All right, if we look at C, I've got 1, 2, 3, 4 odd vertices. So it'll be impossible. Sorry for that. And again, it's because I have 4 odd vertices. Okay, let's look at E and F. So you'll notice with example E, I have exactly 2 odd vertices. So that means I'm not going to have an Euler circuit. All right, so for the Euler path, I'm going to go ahead and start with vertex E. So I am going to go from E to C. I think you see there's no other choice, right? And then C to A, and then A to C, and then from C to D, and then I went from D to B, and from there to A, and then to D. So let me go ahead and write that path out. So again, please notice that I started and I ended at the two odd vertices. Okay, it appears that I forgot to number F, so give me a second. Okay, that's done. So perhaps you see again that we have exactly two odd vertices. So again, no Euler circuit. All right, I chose to start at D this time. Okay, and I went to A, and then I went to C. Now that loop is still an edge, so I'm going to circle back down to C again. And then I went to B, and then clearly F because I can't do anything else. And then I went to E, and while I'm there, sorry, that's 6. Then I went to E and did that loop. And then I went to D, and then C again. And then that allows me to finish back to F. All right, so let's write that path down. D, A, C, C, B, F, E, E, D, C, F.